Hello, this is Mr. Stansbury. I'm going to take you through the second part of calculating probabilities. At the end of this, you should be able to say I can use the normal distribution to solve real-world type problems. Okay, so part 2 of this video, we're going to start with example 3. The variable x is normally distributed with a mean of 300 and a standard deviation of 18. Find the probability that x is going to be greater than 295 but less than 313. Okay, so now if like 300 is our mean, and then if we were to add 18, we'd go up to 318, which you notice does not fit nicely with this number. And if we did 300 minus 18, that's 288. No. Sorry, 282, and that also doesn't line up with this. So we need to have a different technique for this. And what we want to do is actually use our graphing calculator, and we're going to use this the normal CDF. Okay, so what you want to do, get your graphing calculator. I think this one should work. Let's double check. So what we want to do is do second variables, which goes into distribution. Okay, and there it is. Normal CDF is what we want. Okay, so what we do is we push enter. Now some of you are actually going to go through and you will push normal CDF, and you're going to get this little menu of options to put stuff into. I'm going to see if I can find an example of that. Okay, so here's a TI-84 versus a TI-83. So on this one, I do same thing, second variables, which is the distribution. And then I want normal CDF. Now I push that, and it gives me this. And actually, these are going to end up calculating the same thing. This one just kind of takes you through a little checklist almost type thing here. So we'll do it on both of these at the same time. It'll be a little weird, but it should. I think it'll help out. So what this is asking for is what's the lower bound? What's the lowest we want this value to possibly be? And in this case here, the lowest value we want is 295. So we're going to do 295 here. Okay, I'm going to do it all on this one, and I'm going to show you, and then we can put it over here as well. Okay, so the lower, and then now the upper bound, we want it to go all the way up to 313. So 313 for our upper bound. This, remember, that's mu. That's our standard deviation, which is, sorry, not the standard deviation, but the mean, and the mean was 300. Okay, so mean was 300, standard deviation is 18. So mean is 300. And then the standard deviation is 18. So we put all that there. And then here's the nice part about this. It goes through and it says paste. And what it does is it pastes everything into this normal CDF function. Okay, so if your calculator looks like this, you just have to remember or write down somewhere so that you can get this, so you don't have to remember. But it's going to be the lower is going to be the first number. So on this one here, we would just simply type in 295 and then separate all your values, your 4 values, with a comma. So 295 comma, and then the upper value is 313 comma, and then the mean was 300, and then another comma, and then our standard deviation was and is 18. Okay, so we push enter there and we get 0.374. We push enter here and we should also get 0.374. We get the exact same thing. Okay, so this here, it just goes through and it actually calculates what percentage. If it's a normal distribution, hence normal, if it's normal distribution, about 37.4% of the data should be between 295 and 313 if the mean is 300 and the standard deviation is 18. Okay, so this is going to be a lot of calculator work stuff here. Okay, so let's get rid of one of these. We don't need both of those up there. Let's leave this one on here. It's a little bit nicer. And so let's see this one here. So we're simply just going to write down our answer, 0.3. I'm going to go 0.374. It doesn't say where to round to, so that's pretty good, which is 37.4% chance, but this is just fine. Okay, something that might be handy in case you get this wrong is to write down what we entered into the calculator. So we did normal CDF, and then the numbers we put in, 295, that's a 5, comma, 313, that was a lower bound, upper bound, and now the mean, which was 300, comma, and then the standard deviation, 18. If you write that down with your work there, if something goes wrong with your answer, it's going to be really easy to figure out what went south, because we'll be able to look up there and say, oh, this was supposed to be a different number or something like that. Okay, so we do the same idea here with these two as well. So let's bring our calculator back up, and we're going to do second variables distribution. We're going to go back into normal CDF, and now it's going to have all the data that we just entered in there. So now we're going to change it. Now this says x is less than 305, so we want that to go all the way down to 0. So I'm just going to put lower bound is 0, upper bound is 305. And the good news on this is the mean is still 300 and the standard deviation is still 18. So we push all of that, it pastes it in, and then we push enter, and the probability of that is 0.609. Right, or 60.9%. But again, that is just fine for that. Okay? And there's what we entered into the calculator. So for this last one, similar idea. Second variable, which is distribution, go down to normal CDF. Now we want to know what's the probability that's going to be greater than 320. So the lower is now 320. And then the upper is going to be something really big. So, I don't know, we can put in 1,000, 10,000, whatever. 1,000 should be just fine. You know what? Let's just put in 10,000 just for kicks. So, and then the mean and standard deviation are still the same. So we go down to paste, enter, and it gives us a probability of that is 13.3%. 13.3%. Okay, again, just leaving it as a decimal is just fine. Okay, I got one other example to look at, but before we do that, let's take a quick comedy break. All right. Example 4. The times to get down the hill at the annual cheese rolling race at Cooper's Hill, United Kingdom, are normally distributed with a mean of 37.5 seconds and a standard deviation of 5.1 seconds. Calculate the probability that a randomly selected participant took at least 40 seconds to get down the hill. Okay, so let's see. Let's just write down our important info here. We've got the mean is 37.5. Our standard deviation is 5.1. And this one here is at least 40 seconds. Okay, so we can crank out our calculator here, and second distribution, normal CDF. Okay, and they want to take at least 40 seconds. So we want 40 to be the low, and then the upper to be something really big. 10,000 should work. Standard deviation on this one is 37.5. Sorry, the mean, I keep saying that backwards. And then the standard deviation is 5.1. Okay, go down to paste, enter, and paste it in, and that tells us that there's about a 31.2% chance. 0.312. 31.2% chance that it's going to take at least 40 seconds to get down the hill. Okay? Out of 20 randomly selected participants, 8 or less took at least 35 seconds to get down the hill. What's the calculated probability that that happened? Okay, I'm going to change this to make this a nicer problem, because that's what you're going to see a little bit more in our textbook. Let's change it back to take at least 40 seconds, because that's exactly what we figured out up here. Okay, so what we're going to do to figure this out is we are going to go back into our calculator, but instead of going back into the normal CDF, this is where we have 20 randomly selected participants. 8 or less took 40 seconds or more to get down the hill, right? At least 40 seconds to get down the hill. That is back with our, go back into distribution, and that is back to our binomial distribution, right? So we go down here. Sorry, this is a little slow. Binomial CDF. Okay, so we'll do enter on that. Number of trials, there are 20 trials. The probability of someone taking 40 or more seconds, at least 40 seconds, is 0.312. That's why I wanted to change it to this one since we've already calculated that. Okay, and then we want 8 or less. Okay, so if you remember, we have this lovely sheet from the last chapter that we were doing binomial probabilities with. So we want to know 8 or less. So that is 8 or less. So that would be at most 8, right? So we would want to use this one. So binomial CDF, sorry, our N is number of trials, P is the probability of success, and we want to actually put 5 in because it's going to count all the way up to 8 on our probability here. So back in here, our X value we want to put in as 8. Push enter, paste, and then enter again, and that tells us nothing because it's not calculating. And there it goes. 0.86. So that's 0.862. So there's an 86.2% chance that 8 or less took at least 40 seconds to get down the hill. Okay? And then if there were 183 participants, how many would you expect to take more than 30 seconds to get down the hill? So what we'd want to do on that is figure out what's the probability of taking more than 30 seconds to get down the hill. So we would want to go back into our distribution, normal CDF. Okay, so let's see, more than 30 seconds. So the lower is going to be 0. Okay, and then our upper, let's see, wait, more than 30 seconds, sorry. So our lower is going to be 30. Our upper is going to be some big number, 10,000. Just got to put some big number in there so we're in good shape. And then our standard deviation for this is still the same, 37.5. Sorry, our mean, and our standard deviation is 5.1. Okay, so this will tell us what the probability of someone taking at least 30 seconds to get down the hill. It should be pretty high, right? Yeah, 92.9%. So that would be 9.929. And then it says now there's 183 participants. So if we're expecting 92.9% of those 183 participants to take it more than 30 seconds to get down the hill. So we take 0.929 times 183. And that will give us some number. We already have 0.929 in there unrounded, so let's just do this times 183. Push enter, and we would expect about 170 people. So 170 of the 183 we would expect to take more than 30 seconds to get down the hill. Okay? All right, that's all we have for calculating probabilities. If you have any further questions on this or anything else, please feel free to ask. Thanks.